at least you'll be in position to tell where you find the challenges. Still, we can share together and correct in those scenarios that I'm going to take. So, as we are still continuing with our topic about cells,
Yeah.
is what we looked at the other time. Okay, I'm sorry, the host is just unmuting me. I just request the host to make me a co-host such that it will not be disturbing. So, we looked at the primary cells the other time. And while we recall on the primary cells, because mostly we are going to look at two types of cells, the primary cells and the secondary cells, whereby the other time we looked at the primary cells. So I think I will be in position at the end of this lesson, we shall be in position to give you some scenario questions that you can try about this topic of cells. Now we look at this topic of cells. Is trying to take us such that is preparing us, we shall be in position to go and look at electricity. So now when you look at the primary cells, the other time, when we looked at the examples of the primary cells where we said we have the lead acid accumulators, then we have the nickel-cadmium was also part of it. So those are the ones that we are going to look at in the secondary cells. So, and we know according to the definition of secondary cells, you find that for this type of cells, after you using it, you can be in position to charge it and still it gains the energy and you be still in position to use it. Like the way we say like batteries. That's why you have the lead acid accumulators. When its power gets down, the energy from that battery gets down, you can recharge it. After recharging, then you can still use. Those are the primary cells that we talk about. But not the secondary cells, pardon me. We saw from primary cells that once you finish to use it, you will not be able to, once the power of the energy gets down, you will not be able to recharge it. Those ones were primary cells. Now, when you look at the lead acid accumulator, now you find that for them, they are consist of lead oxide, whereby in this lead oxide, we have this lead oxide, we are going to have, when I say lead oxide, because remember lead has an oxidation of 2, lead itself. So then when I see oxygen also has an oxidation state of 2, then sometimes we can call it lead peroxide. So now when you talk about the lead oxide, we have both in it. We are going to have both the positive electrolyte and the negative electrolyte, which means our lead is going to act as the negative electrolyte. Then we are going to have like when we talk about the peroxide ions, those are the ones that are going to be like the positive electrolyte. Then after you knowing this lead oxide that it's having the electrolytes, then what do we use in it? What is forward in that lead acid accumulator is what we need to know. You find that in this lead acid accumulator, we use sulfuric acid as an electrolyte. Now, when you use the sulfuric acid as an electrolyte in this, you find that the work of the lead acid accumulator is going to supply much current, is going to supply too much larger current than the dry cell, which means when you look at the secondary cells, for them, they are too strong compared to the primary cells. Now, this lead acid accumulator supplies too much current compared to the dry cells. Why does it supply too much current compared to the dry cell? Because it consists of the 6 accumulators in series. Like when you look at the battery, for example, you look at this battery here that we have, this battery. We have, remember the battery, you find that it's going to consist of of some accumulators like this. We could have the terminals whereby those terminals, when you can open and you'll be able to pour the sulfuric acid inside it. Now, when you pour it, you find that they can be in line. The accumulators are just in line. You find that one will be there. They are just in line. You find that it has 6 of them. Now, when it has the 6 accumulators that are in series, when you say that in series, they follow each other. Now, there is a time of during the discharge. Now, during the discharge means now you connected this battery maybe to a certain, now the battery you've connected it maybe to a certain AC or to a certain speaker such that now at that time it's going to be discharged. You find that both the electrodes are going to change to lead sulfate. And now the acid, the sulfuric acid that which is inside here is going to become more dilute. That's the time it is going to be discharging. Now let us look at this diagram. Now when you look at this diagram that we have at this point, this one, because this is just when we give you this example, this battery, this is an battery. This battery is what we call the lead acid accumulator. Now, like this battery here that we have at this point. That now, just when we draw it, if I have the lead and the lead peroxide, you find that our lead here that we are having at this point, the lead you have at this point, this is where we have, because this one is now our electrode. Now this is where we have the negative electrode at this point. Then now this lead peroxide, or we can say, now when I say lead dioxide here, it means I have now lead 4, I have lead 4 oxide here. Now this is the lead 4 oxide that I have at this point. Whereby when I say lead 4 oxide, I get lead which has an oxidation state of 4. It has an oxidation state of 4. Then the oxygen has an oxidation state of 2. Now, by the time of crossing that, the 2 is supposed to come here and the 4 comes this side. This 4 can divide this 2 and it reduces, which means this side is going to be a 2. And here now we shall not have anything. Then we come up with the lead 4 oxide like this with the 2 that we have at that point. This lead 4 oxide is the one which is a positive electrode. Now the lead oxide, this lead, the lead, not lead oxide, the lead we have from here, itself is what we call the negative electrode. Now we said that sulfuric acid is the one which is going to act as an electrolyte. Now what happens, that's why we have this, the whole of this is our dilute sulfuric acid is diluted, is what we have now at this point. That's why we have it at this point. Now what happens? So now at least if you're drawing the lead acid accumulator, you can draw it in that form. You can come up with your sketch, just say, you can come up with the drawing of this form where you're going to have the electrodes. These are our electrodes that we have. Electrodes are both positive and negative. We have a positive electrode and a negative electrode. Then when you have these electrodes, now we need to dip them into the acid, an electrolyte. What's why we are dipping them into the acid like this. Now when I dip them into the acid, then I'm going to get a wire and I connect this electrolyte such that they can be in position to supply the current. And even electrons will be in position to flow. We shall be able to see the flow of electrons. Remember, the electrons flow differently from the current. Now, once I connect here and then we have the load here, now you can name here that I have lead 4 oxide here. You looked at in chemistry, you look at oxidation state, which is our positive electrolyte. Then we have just a metal, which is lead. Why do we take lead at this point? Just a metal. We know from the reactivity series, an element, a metal which is more reactive is most likely to work faster. So, for example, if I'm picking, when looked at the primary cells the other time, when we are looking at it, first of all, when we are dealing with simple cells, we saw we're using zinc and copper, and we picked zinc to act as a negative electrolyte. Why do we pick zinc more than copper? Because zinc is more reactive in the reactivity series than copper. So zinc will be able to react faster and it will be in position to supply, because at that point, when if zinc is more reactive, that is the time you find that that cell is most likely to work at a faster speed and it will be able to supply. The electrons will flow, and even there will be a flow of current at a faster speed that we see at that point. So that's why we are taking lead. The lead being more reactive, so we are taking lead at this point, and we have the lead oxide. So now this lead, which is more reactive, is the one we are taking as a negative electrode. Then now this one, we take it as a positive electrode. So whenever you're picking metals when you're dealing, the one which is more reactive is the one which is supposed to be a negative electrode at that point. So now we want to see, after you knowing a negative electrode, which is our porous lead or just lead metal, and our positive electrode, which is our lead for oxide, or someone can say lead dioxide, and our electrolyte being dilute sulfuric acid. That's why you have that water. When you have this water and sulfuric acid, that means the acid is diluted. That is dilute sulfuric acid, because some water was added into it. If water was not there, it would be concentrated sulfuric acid, but we are using water, so that's dilute sulfuric acid. So to make the lead acid accumulator, you must have the three things. Our electrolytes must be dilute sulfuric acid. Now, after you understanding that you've known that, now what happens? First of all, like we have this statement that when the battery is fully charged, what is the relative density of the acid? That one is just been knowing. And once the relative density of the acid is 1.25 when it's fully charged, then after, when the cell discharges, that battery has discharged, you find that the relative density of the acid is going to decrease to fall to 1.18 when the cell is discharging now at that point, because it's going to be reducing now at that point. So what now, when we see that it reduces, now we want to look at how does the lead acid accumulator works at that point. Now we look at this. First of all, when you talk about how the lead acid accumulator works, the first thing you need before we come to the care and maintenance of the lead acid accumulator, the things you should know is, like when we started earlier here, when we're introducing our lead acid accumulator, because if they tell you that our lead acid accumulator, first of all, consists of the lead oxide, which is lead peroxide, but when you look at this thing here, there was just a mistake, which is in the thing. Should be lead for oxide that we have at this point, which is acting as a positive electrolyte. We shall correct it after some time. Then porous lead as a negative electrode. Like I'm introducing, if you want to just introduce first of all lead acid accumulator, then the electrolytes is dilute sulfuric acid is what we have at that point. Now then you now speak, how does it work? You find that the lead acid accumulator supplies more larger current than the dry cell, because it consists of 6 accumulators that are arranged in series, and during its discharge, you find that both electrodes change the lead sulfate and the acid becomes more dilute. That's the way you explain it. If you want to determine how it works, you start by introducing what it's having, that what is it made up of first. After being made up of it, what does it contain? You talk about electrodes and electrolytes. After talking about it, tell us how does those accumulators being arranged? How are they arranged? How many are they? You tell us those things. After, talk about during discharge. What happens to the electrodes? Those are the things you should tell us after the acid. Now, if you discharge it and both electrodes change the lead sulfate, that they have changed to be the lead sulfate, what happens to that acid, our electrolytes? You tell us in there. Now, how do you maintain this battery, the lead acid accumulator? Is what we want to look at. That's why you find that sometimes you find that these batteries, people can be working, can be using this battery. So you can take a battery to charge it in a certain place where they are charging. Then after some time, you find that the battery is not charging. Sometimes you can be using a battery, but when you use that battery, you find it stopping to work, yet it is the acid is still there, the energy, it's still having energy, but it has stopped working. Now, you might not be knowing the reason behind it, but you as a physicist who has studied the cells, you will be in a position to know how you can care and maintain the lead acid accumulator such that you can avoid such things. Now, the first thing we need to know is that lead acid accumulator, we use it for a long period of time. That's why you find that when they are using a battery, we use it for a long period of time, provided the following conditions are taken for you to use it for a long period of time. You find that the first thing you need to know for you to use it for a long period of time, the liquid level must be maintained using distilled water. Why do we maintain the liquid water? First of all, that the liquid level to be maintained using distilled water. The work of that distilled water, what we pour there, it is going to ensure that the electrodes are not exposed. That's the first thing you need to know. If you want to make it to work to work very well, that's the first thing you need to know for it to work for a long period of time. Then now, again, what you should know that cell should be charged relative. It is going to be, should be charged if the relative density of the electrolytes falls below 1.125. That's why you're supposed to take the battery to charge. You don't just need to go and change. That's why I find sometimes we normally advise people, if you have your phone and the phone is at 40, then you're going to put your charger and you charge it again, that phone, you're weakening the battery at that point. But there's a time, there are phones that are said that once it clocks 15%, it even tells you, you charge your phone, plug a charger on your phone, which means those phones, once it reaches 15%, it needs to be charged. And when you charge your phone at 15%, you will not be weakening your battery at that point. That one is okay. But about 15, from 16% onwards, that whenever your phone is about 15 and you're trying to charge it, you'll be weakening. Now, this battery is also, if the relative density of the electrolyte that dilute sulfuric acid, this relative density is not below 1.25, we don't charge it. So we charge that cell if the relative density of the electrolyte, where our electrolytes dilute sulfuric acid, falls below 1.25. That is thing you should know also for when you're maintaining them. Now, we are going to look at, again, the battery. We know that the battery should be clean, should be kept clean. Why do we keep the battery clean, and what do we use for cleaning the battery? Those are things you should know. You find that the battery should be kept clean so that the current does not link away across those terminals that we have at that point. Now, for example, if your battery is not being clean, that you look at the terminals are too dirty, now at that point, you find that at that point, your battery you find that the cell is most likely to link now at that point. So we keep the battery clean. We are supposed to keep the battery clean such that the current does not link away across the terminals that we have at that point. Then, another thing you should know in your battery, that when you're dealing with that battery, you find that the positive terminal should not be connected directly to the negative terminal. Once you make such a mistake, there is a short circuit is also going to happen from there, which means too much current is taken from the cell, and it leads, you find that at that point, it is going to destroy the cell. So the thing you need to know about that battery, for you to maintain, the positive terminal should not be connected directly to the negative terminal. Once you do it, too much current is going to be taken away from the cell and it's going to destroy that cell. Then the battery should be charged regularly and should not be left uncharged for a long period of time. For example, if you have that phone and you find that you've left the phone, it has gone 0% and you keep it for some like 1 week or 1 month, the day you're going to try to charge, even you might find that that battery might stop working, or you might charge it for almost 30 minutes to just give you 1% of it, which means at that point, there was effect of charging current. It means like this battery, if the battery should be charged regularly and should not be left uncharged for a long period of time. Why? We know that the effect of the charging current is to change the lead sulfate onto both positive and negative plate into the lead to oxide and to return the sulfate into the electrolytes. So there you should just pick how should you maintain the lead acid accumulator. You pick the ones you can remember mostly. Talk about the battery, that the battery should be charged regularly and should not be left uncharged for a long period of time. That can be simpler to you. Talk about that the positive terminal should not be connected directly to the negative terminals. If it's connected, you find that there will be a short circuit. When you talk about the circuit, it means too much current is taken away from the cell now at that point. You talk about that. Then you say that the battery should be kept clean so that the current does not leak away across the terminals. Then you talk about that the cell should be charged if the relative density of the electrolytes falls below 1.125. You look at how you can maintain it when you're talking about the lead acid accumulator. Now, if we talk about the nickel-cadmium cells, that one we normally call, sometimes you can say the nickel ion accumulators. Now, when you talk about the nickel-cadmium cells or the nickel ion accumulators, you find that it is electrolytes that these nickel-cadmium cells use is just, it is an alkaline. This time we are not using acid. When I talk about an alkaline, this is where when talk about alkalides, that's why you talk about potassium hydroxide, sodium hydroxide, sodium peroxide. Yes, like sodium peroxide also is an alkaline. Yes, that one. So now you find that nickel-cadmium cells use an alkaline as an electrolyte. So for example, the potassium hydroxide. Now the potassium hydroxide is an alkaline. This time, this one does not use an acid. It uses an alkaline. So differentiate between the lead acid accumulators and the nickel-cadmium cells or the nickel ion accumulators. You find that the potassium hydroxide is going to be dissolved in water. Then the positive electrolytes will be the nickel hydroxide, and the negative electrolytes will be iron. If we are not using iron, we can use cadmium, because here when you talk about nickel, you find that the nickel hydroxide can be the positive electron. Then this cadmium that we have at this point, this cadmium here that we are having at this point, or this ion that we have at this point, those ones, that one is what we call the negative electron. Now, when we have those ones, what is the use of the alkaline accumulator? That a battery that has an alkaline and the battery that uses an acid, what's the use of alkaline accumulator compared to the lead acid accumulator? Because here we have the alkaline accumulator and the lead acid accumulator. One want to see which advantages are there between, like, advantages of lead acid accumulators compared, advantages of alkaline accumulators compared to the lead acid accumulators. That what are the advantages of using an alkaline compared to using an acid is what we want to look at in this point. You find that the first thing is, when we are looking at the advantages of these ones that we have at this point, the first thing is, remember, we looked at the lead acid accumulator, that for them, they last for so long. Now, which means, but when I'm using accumulator, it lasts, you find that an accumulator lasts longer, they are keeping charge longer, and they can be left in a discharged condition without any harm. That is an alkaline, not an acid. However, an acid also, which means when you're giving the advantages over it, you're going to talk about one advantage. You can say an alkaline lasts longer. Then an alkaline keeps charge longer compared to the lead acid accumulator. Then that alkaline also can be left in a discharged condition without an that you can leave that alkaline to be in a discharged condition, that it can be discharging the power or the energy, it can keep on discharging without any effect that it is discharging from there. But the acid, time can reach that you not supposed, once you leave the acid discharging for so long, time can reach, at that point you find that for it there will be some harm that can be there. Now, what are the disadvantages of using this lead acid accumulator? One of the disadvantages that the alkaline has is you find that it is just a relatively smaller EMF, electromotive force, than the lead acid accumulator. Its EMF is very small compared to the lead acid accumulator. Now, which means if the EMF is very small, during the time of discharging, the EMF tends to fall continuously. You find that the EMF just falls rapidly at that point because already the EMF is very small. Now, during discharging process, you find that EMF continuously discharges. It is going to fall continuously during the discharging process. Those are the advantages of the acid, the alkaline accumulators that we have at that point. So, for example, if I'm talking about the discharging process, that if I'm speaking about the discharging process, you find that if I have a power supply, that I will have my circuit where I have the positive terminal and the negative terminal. Then I can have the switch. Then we are going to have our batteries here. Then we can have our rheostat like that. Now, what happens? Now, this time I want to say when we are charging a circuit, we want to see how does it charge. The first thing is, now I have the lead. I want to charge the accumulators. Now is what I have. Now these are negative. This is a negative. This is a positive now at this point. When you look at those terminals now at that point. Now this is a DC supply. Now the work of this DC supply, still we have a negative and a positive. It is to charge the accumulator. Now this DC supply will be this DC supply that we have at this point is the one which is going to be charging the accumulator. So it's going to charge this accumulator that they have. That's why you have the DC supply and the accumulator, which means the first thing you need to know, if I'm going to say, because I want to see how can I charge an accumulator, the first thing is the supply voltage, or we shall say that the supply must be a DC. So we must use the DC supply, and the current is going to flow in the opposite direction of the greater EMF than that of the accumulator. What does it mean? Which means the positive terminal of the supply, this positive terminal, must be connected to the positive terminal of the battery. Then the negative terminal of the DC supply must be connected to the negative terminal of the battery. That's what you need first of all when you're dealing with the connection. Connect the positive terminal of the DC supply to the positive terminal of the accumulator. Connect the negative terminal of the DC supply to the negative terminal of the accumulator. When you're charging the battery, that's the connection that we have at that point. Why? Because we know that is this supply, the current is going to flow in the opposite direction of the greater EMF than that of the accumulator. Now, so what does it mean after you connecting that? Like when we are done with connecting it, first of all, after connecting the positive terminal to the positive terminal of the accumulator and the negative terminal of the battery to the negative terminal of the accumulator. What happens now at that point? The next thing is, then you keep on adjusting the current. The current is going to be adjusted slowly. You'll be adjusting the current. What happens when we are adjusting the current? We keep on adjusting the current, not until we get the recommended value at that point. So once we get the recommended value, but before charging, the first thing is these accumulators that you have at this point. Before you start charging these accumulators that you have at this point, make sure that before you start charging these accumulators, make sure these accumulators are going to be topped up with distilled water. You first pour distilled water. Because you pour the acid in the accumulators, you're going to pour your dilute sulfuric acid here. After pouring it, you top it with distilled water. After topping it with distilled water, then you charge it. Now at that point, you find that when you're charging this accumulator, it is going to be charged slowly with a smaller charging current. Why do we charge it with a smaller charging current? We want to avoid destroying the grids or the terminals that we have from there. But when this accumulator becomes fully charged, when it becomes fully charged, you find that, remember when this accumulator, we had lead oxide, or we had the lead peroxide at that point, whereby now when we have the lead peroxide, we have the hydrogen gas. In that hydrogen gas, there is oxygen gas. The oxygen gas, we have lead also as a metal. Now, it means when the accumulator is fully charged, the hydrogen is going to be enveloped from the lead and the oxygen. Because the lead, when I combine lead and oxygen, is where I got lead oxide at that point. So now from that lead oxide, when the accumulator becomes fully charged, that's where the hydrogen is going to be involved. So now what happens when you're being asked that, explain explain the charging process of the accumulator is what I am interested in. If you're being asked to explain the charging process of the accumulator. Now, it means if you're to explain, the first thing is draw your diagram. Draw your circuit that you're going to have, first of all, a power supply. That is your power supply. Then put a switch somewhere. This can be your switch. Then you put that battery, the accumulator. Maybe it's the one we can call. We can have the accumulator here. That this is the accumulator. Which is that one. That is the accumulator. Then you connect this. Remember this terminal is long. Connect it. Then we put a rheostat here, which is our rheostat. Then you connect it to this. Now, after connecting it, that you've drawn it and you've connected that we have connected this into this. Now, this is where we have the negative charge and we have the positive charge, so also negative charge and the positive charge. This is the DC supply, because our power supply must be a DC. DC supply is what we have from here. Then this accumulator, you say the accumulator is here. Then this is a rheostat, then this is a switch. Now you're going now to explain it. Then you're told to be explained. You say that the power supply must be direct current, because we are dealing with direct current DC supply. So which means we should use the DC supply and the flowing. Why do we use the DC supply? You find that it means such that the electrons are going to flow in the opposite direction of greater EMF than of the accumulator. So you find that the greater EMF is going to be on this. So that side, they are going to be flowing from here. This one is going to be flowing from this side. Then what happens? You're going to say that the positive terminal is connected. The positive terminal of the power supply, of the DC supply, is connected to the positive terminal of the battery. And after connecting, which means the negative terminal of the DC supply is connected to the negative terminal of the battery, and the current is adjusted to a recommended value. After you connecting, you're going to keep on adjusting the current to a recommended value. What you should know is, but before charging, these accumulators must be topped up with distilled water. That's the first thing that you need, because we can't pour the whole acid into it. We pour distilled water into it, such that why do we pour our distilled water? We pour distilled water in order to dilute the acid which is inside. Remember, we have sulfuric acid inside. So now we are going to top up with distilled water in order to dilute that acid at that point. That is, you would have explained how a lead accumulator is charged. Then you know, you take some. When I'm charging the lead accumulator, the first thing you should know that charging is done slowly with smaller charging current. And that won't destroy the grid. So it is charging slowly with a smaller current. That's why that when you take a battery in the morning to charge, it can take like 12 hours, which means it is charging slowly with a small charging current. That won't destroy the grids, the terminals of the accumulator. Then when that accumulator becomes fully charged, the hydrogen gas enveloped is enveloped from the lead acid, is going to be enveloped from the lead and the oxygen, which means it's going to be enveloped from the lead peroxide. Is where it's got from all lead oxide at that point. So those ones you just take note. It's not part of the explanation. Now, that's why I said that lead oxide. Now, what now happens? That is all about charging the DC, charging the accumulator. Now, in case someone is having any question before we go to the next thing, because I might not be knowing whether we are getting on, but at least we should allow some few questions to be asked such that we can know. So now, before we go to look at this, I would request, in case someone has a question, we have Patricia. We have 4 hands. I will be allowing all of you. We can start with Patricia. She can ask her question. After Patricia, Linda can ask. People have a lot of questions. We have Danielia. Okay, Patricia, you ask. You unmute and ask.
Yeah, thank you, sir. So would you please go back to the slide of the part for charging an accumulator?
Charging an accumulator.
Yes.
Yes.
So like when you were explaining, there's something you said that first, what's an example of any example of direct current supply? Then the next question is like, there was a point you're saying that the direct current for it's going to flow, like its direction of current is going to be opposite to that of the accumulator. So I wanted to inquire like which direction, for example, the accumulator, like does it have a specific direction of current to which it flows to, like maybe from positive to negative or negative to positive?
Okay, thank you so much for your question. First of all, when we talk about the example of an accumulator, is what we have said. We can talk about the lead acid accumulator. For example, if I take you behind this point where we started, when we're dealing with the secondary cells, these examples of secondary cells, we had the lead acid accumulators that are mostly used the car radiators. That a car battery, like when you have the car battery, those batteries that are used in the cars, those are what you call the lead accumulators for it. But now the alkaline, when I talk about the alkaline cells, whereby when we say the alkaline cells at that point is where I talk about nickel ion cells, or I can say nickel-cadmium cells. Those ones are used in digital cameras and digital watches. That's where we use them. So any battery, all those batteries that you see that are being used in the cars, those are lead acid accumulators. They have there's an acid. Those batteries are called lead acid accumulator, where lead is a negative electrode and lead peroxide is the one which is the positive electrode. Then the acid inside is dilute sulfuric acid, which is used as an electrolyte. That is, so in case you're being told to give an example for accumulator, you give lead acid accumulator. If they tell where is it used from, you say that those ones are used in car batteries. They are just used in car batteries. Those batteries that are used in cars, those are accumulators we are talking about. You get it?
Yes.
Now let us, when you go back to the currents that you say, when we talk about this flow of current, when we are dealing with charging an accumulator, the first thing is this accumulator, when we are charging it, we want, remember, you see when we are charging a battery, when I talk about direct supply of current, it means if I get a switch, like, you go to a socket, and first of the socket, you plug an extension. After plugging an extension, then now that battery, you need again a charger to pin on it. Now that one would be direct current. For example, your phone, you're going to get a charger of your phone, plug into an extension, then you put it. Your phone is not using direct current at that point. That is not direct current. Direct current means go and put a wire on the socket. You connect the wires. For example, if some students or from home, you get a battery, you get analog phone. Get it is battery of that analog phone. Tie wires. Get a catapult, that black one. You tie the wires of those terminals. After tying the wires, then you're going to take those wires, you plug it in an extension or you plug it in the socket direct. That's what we call the direct current, the DC supply. You get it?
Yes.
Now, which means when we put it, we are going to connect, that current is going to flow in the opposite direction of the greater EMF than the battery that you placed. That's why you find that those batteries, you're going to connect the negative terminal of the power supply to the negative terminal of the battery, and the negative terminal of the positive terminal of the power supply to the positive terminal of the battery. Is what we connect in that. Do you get it?
Yeah.
So when I talk about the supply today being that we are using direct power supply, it means tie the wires immediately and connect it to an extension or a socket direct by not using a charger. That's what we call about mostly. In simple terms, that's what we call the direct current we talk about in that.
Okay, thank you, sir. I was just confused about the connecting the positive terminal of the direct current to the positive terminal of the accumulator, but I've got it.
Okay, thank you so much.
Thank you.
Yes, Linda, I saw her hand up. Let me unmute you. I am no longer seeing Linda. We had given her, let me give Joshua. Yes, Joshua, you unmute. And
yes, teacher. I have a question.
Yes.
Does that real start that you talked of that has an arrow, is it the one that controls the amount of current?
Thank you so much. Yes, when you have the rheostat, remember, if we were not having this rheostat at this point, you find that too much current will be flowing here, because remember, we're using direct current. So now this rheostat controls the amount of current, does not allow too much current to come, because if too much current comes here, you find that it's going to spoil the terminals from here. We might see a short circuit taking place at that point. So that's why you have the rheostat here to control too much current. You get?
Okay, teacher. How about the side with the greater EMF? Is it from the positive side of the DC supply to the positive side of the accumulator, or the negative side?
Now, this EMF, remember, we have too much current at this point here. You see, when we have this supply, this is where we have too much EMF. Now, when you look at here, the EMF is too small from here, because this power supply, now, before we say that, what's the flow of current? Current flows from a positive terminal to a negative, or a negative to a, how does current flow? From the positive to a negative, or a negative to a positive?
Okay, may I remember it flows from the positive, no, from the negative to the positive.
When we looked at yesterday, the other time when we are dealing with a simple cell, for example, when we are looking at the simple cell, we showed you how electrons were flowing in this diagram here. We showed the flow of electrons and the flow of current. There is a difference between, you find that for current, it was flowing from the positive. When you look at the current flows from the positive to the negative. Then electrons are the one that are flowing from the negative to the positive. That's why when you come and look at this circuit that we have at this point, the current is flowing from the positive to the negative. You get it? So, which means
Yes.
the greater EMF. So, where does the current pass? It's going to pass from this positive coming to the negative side. Now, when you connect it from the positive, it moves to the negative. So, which means it is this greater EMF is found at this positive side. You get?
Okay. Thank you, teacher.
Yes, we may allow if another one asks a question. I am saying, Emmanuel. I think no one else asks a question. Yes, Emmanuel. You unmute and ask. Yes, Emmanuel. Unmute.
Yes, teacher, mine is very brief. I was asking if you can continue enlightening on how excessive charging, that whatever destroys the battery, since you told us that it is not advisable to leave the phone on charger for so long also. Then how is it, how does that, and also me personally, I thought when the phone is fully charged, it is automatically, it has to like stop charging, something of that sort. So I need more emphasis there.
Okay, thank you so much for that. The only way, in time to come, you're going to study electrostatic. You're going to study about discharging and charging a capacitor, because a phone is just a capacitor, it's a device. So it is studied in capacitance. Now, there are those phones that are connected automatically, that when it becomes full, is going to show you that fully charged, but is you going to leave it connected to. Why don't we allow phones after becoming fully charged to continue charging? Because there is this charging means at this time right now you're using your phone is discharging at this point. Or sometimes you can connect your battery, your capacitor somewhere to charge. Then after ease of charging is again discharging. It's reducing. You see the percentage reducing, ease of increasing. Your phone is discharging at that point. But the major aim of us not allowing the phone to continue charging when it becomes 100% is the first thing is to avoid weakening the battery. That is the first thing, because there are those phones that are not set automatically. Now, remember nowadays we are going to the digital world that everything is being set automatically. Now the phones are coming in a modernized way that once it becomes fully charged, they no longer allow any current to flow into the capacitor. So which means those ones are safe, but there's an extent when you touch your phone, it's becoming too hot at that point. Now, when the phone, when you see that when you tap on the battery, it's becoming too hot. So even after becoming 100%, you leave it, it's not cooling, but you find that it's still hot. Now, that battery, you're trying to weaken the battery, that the power, the percentage which has entered into it is not enough, as if you want a more percentage. The major thing is to avoid weakening the battery. That is mostly the major thing. That's what they say, that once it becomes 100%, you remove it from charge automatically. However, phones nowadays disconnect immediately after charging, after fully charged, is just disconnects by itself. You can check and find that it's already disconnected at that point. You get my point?
I try to.
Yes. Have I answered your question?
Yeah, start from that. Yeah.
Thank you so much. I think the questions are done because I'd allowed people to ask. We may, in case anyone asks, you raise up the hand. I might not be in position to read the charts, but if there are those ones that have read the charts and you see that there is a question that I've asked from there, you feel free to raise up the hand and we see that question which is being asked from there. Now, before we look at other sources of EMF, because we have this, let us look at, I want to show you something on this document as we are summarizing up now, because we are trying to summarize them. It is, let me share this document and we look at something from here. Teacher John? Teacher John? Teacher John? Okay. Oh. Yes, members, we apologize for what happened. I think the network just disturbed, but by the time we came back, the host was not allowing us to speak anything. So I tried to text the host to allow us to speak, but the host was not first of allowed. So we apologize. It was just a network issue that had just jumped. I don't know how did it jump. So I just wanted us now to summarize it now. The lesson as the time is also ending. We summarize with a few things because we might not be able to start. I was picking some, actually I was picking a certain question. That's why the network had jumped. I wanted to share it on the screen. Then the network jumped. But I'm going to share you those items in the groups, that the WhatsApp group that you belong. Mr. Steven will share with you. So we use this time in case people have, according to what we have studied so far. If you have questions, you may ask the question, because I don't want us to continue because time is now ending. We can just summarize with questions. I think even I wanted to share the item here, but time is not going to allow us to handle the whole of it properly. So I just wanted us now to summarize with it, and we summarize the lesson in this remaining 15 minutes. So in case, according to what we have looked at, yes, Patricia, you may unmute and ask.
Okay, thank you, sir. Like the alkaline accumulator, is it the nickel something?
Yes, the alkaline accumulator is when we talk about the alkaline accumulator, that is not the type of the secondary cell. The secondary cell, an example of the secondary cell is where we say nickel-cadmium cell, or we can say nickel ion cell. Now, the alkaline accumulator, it is the nickel-cadmium cell or the nickel ion cell that uses the alkaline accumulator like potassium hydroxide as an electrolyte. So that alkaline accumulator is an electrolyte. which is potassium hydroxide, which is used by one of the examples of the secondary cell, which is the lead-cadmium cell. Or if you don't want to call it a lead-cadmium cell, we call it the lead. No, pardon me, not lead. It's called a nickel-cadmium cell. If you don't want to call it nickel-cadmium cell, you can call it the nickel ion cell.
Yeah.
Are we together?
Yes, so like the nickel-cadmium cell, like it's the one with the cadmium electrodes, sort of. Then the one with the iron is the one with the iron electrodes.
Yes.
Okay.
Because
So like how, okay, my question is like, how does the nickel ion cell produce electricity?
now, the nickel-cadmium cell or the nickel ion cell, basically, those ones are used in digital watches and those digital cameras that we normally have. Those digital cameras or the digital watches, they are the ones that use that nickel-cadmium cell. You get? Now, when we talk about how it uses electricity, remember, when you have a digital watch, the digital watch, you charge it after some time. You can use it after some time, you're going to be able to charge it. That's why for it, it's charges and discharges. But after some time, you charge it. But if you look at the analog watches that have those cells, the batteries, once it gets used up, you have to throw that one and go and buy a new one. But if you're too critical, too keen, look at the digital watches. Once the digital watch you find that when the battery gets used up, it has its own charger, where now you're going to plug it into the next session and be able to charge it again. You get?
Yes.
Mm-hmm.
Like, okay, like that's how you recharge it. Okay.
Yes, when you talk about recharging it, still, now when you talk about recharging it, this time around for the nickel-cadmium cells, do not use, first of all, the direct current. It is only batteries that use the direct current now at that point. There's a difference between them. Now, which means when we are charging these ones, that we are charging them, we charge it like the way you charge a capacitor, like the way you charge your phone. You see the way you charge your phone? That's the way those nickel-cadmium cells are being charged. But not like the way we charge the accumulator, that we use the direct current. It's only those batteries that we use in cars. That's why we charge using a direct current. But these ones, we use another alternating current, where you just get a charger, connect to an extension, and you'll be able to charge that capacitor at that point. Like the way you charge the phone, actually it's charged like the way you charge the phone. Time is going to come, we're going to look at charging and discharging. Sometimes you're going to look at charging and discharging a capacitor. And if you continue with the subject up to the advanced level, you will learn more how a capacitor charges and how a capacitor discharges. Then you can understand them all. But you cannot be asked to explain the charging of the lead acid accumulator. No, they can't ask the lead acid cell. You can be asked, how can you charge an accumulator? Whereby when you talk about the accumulator, we are talking about the lead acid accumulator is what they can ask you, but you cannot be asked how you can charge the nickel-cadmium cell. They don't ask you for charging that one to your level. It is on an accumulator. That is the one they can ask you. Are we together?
Yes. Then lastly, you said when you're saying the differences between the lead acid accumulator and the alkaline accumulator, you're like, okay, the alkaline accumulator is better than the lead acid accumulator, right?
Yes.
Yes. So if I were to, like, for example, a plane, an aeroplane, which accumulator would be the best for it? Is it that alkali?
Now, when we look at an aeroplane is made in a different way compared, actually, aeroplane is made in a unique way compared to any other means of transport that you use. Because aeroplane, actually, it moves on space. So when it's moving on space, it is very risky for you, a person. So the way an aeroplane is made, we don't compare it with all even these accumulators that we have from here. It's made into different things. So when we are dealing with it, aeroplane basically, they have their batteries also, but their batteries is not like these small batteries that we have from. So they use different things. To your level, you should not go deep into thinking what battery is used. We don't teach it so far currently to you. We teach you only just about these ones for cars that you're able to see. Because in aeroplane, remember when we are dealing with them, we look at what a person can be able to see. Now, it is even hard to organize a tour to take you to see an aeroplane. And how can you see the battery of an aeroplane and how does it use? So don't first go up to that extent of looking at the aeroplane. It is not taught in this level. Yes, Patricia?
No, sir, I'm done.
Okay. Well, I'm seeing another hand for Emmanuel. Yes, Emmanuel. You may unmute and ask.
Yeah, teacher, me, I just want to take us some. I just want to pray.
It is fine. You may give us a closing prayer as we end. But before you
Yeah,
give us
let's
a
pray.
closing prayer,
Many Father,
no,
thank you for
first
this
wait.
day. Thank you for.
Emmanuel,
Yeah,
before you give us a closing prayer,
yeah.
you may first wait. Let me first, I teach with my colleague, Mr. John. Let me first, if Mr. John is not busy, he may conclude us, then you conclude with a prayer. Yes, Mr. John, are you on? It seems Mr. John is busy. You may just give us a closing prayer. And
Okay, let's pray. All eyes closed, dear Heavenly Father. Thank you for this. Thank you for today's lesson. We hope to put it to practice when the right time comes, and also thanks you for all the activities that have taken place. And as we go throughout the day, give us protection, cover us, and for those who are traveling, give them journey mercy. And our teachers may continue blessing them. Also bless the work of their hands. I pray this having believed in the almighty name of Jesus. Amen.
Amen.
thank you so much. God bless you. So all those ones that will be going back to school on weekends, we wish you a safe journey and you be blessed. God is with you and God will have answered all your prayers. You're all blessed. We wish you a nice study. For those ones that are leaving on weekend, for those ones that will be remaining, because we shall summarize next Wednesday is when we shall summarize all the lessons. We shall be together and we now summarize on that day. We share a lot on that day. So I wish you all the best. Stay blessed. May God continue being with you guys.
Okay.
Sir, thank you for the lesson.
Thank you, teacher.
Okay.
Yeah.
Thank you, teacher, for the lesson.
Patricia, thank
Bye.
you to Patricia. Thank you. Teacher is also.
Okay, like I said, that thank you, Mr. Pio, in the first place. But guys, I know we haven't covered electrolysis in chemistry. When you cover it, things will make more sense. We understand those who are like things are not coming out well. But when you cover electrolysis in chemistry, you realize that things will start now adding up. Otherwise, the other part of cells is the simplest one. We are looking at other different types of cells like the Barton cells, the thermocouple cells, the solar cells, and some others. Those are very simple. So we thank you so much for your time. May God bless you.
Bless you too.
Bless you too.
Bye, everyone.
Bye.